In the lab, the most common form of nitric acid has a concentration of about 68%, where the rest of it is water. It generally works well for most reactions, and it's what I've used in pretty much all my videos where I needed nitric acid. For some more specialized uses though, like as an oxidizer in liquid-fueled rockets, or to make certain high explosives, a higher concentration is needed. This more concentrated form is usually referred to as fuming nitric acid, and in my opinion, it has some interesting properties. For example, it's an extremely strong oxidizer, and it tends to light common lab gloves on fire. So it's usually recommended to work bare-handed if you don't have ones that are chemically resistant. I actually covered this in one of the first videos that I made for this channel, and this is where these clips are taken from. In the comments of that video, there were a lot of questions asking what would happen if I did get it on my skin. Is it truly better than not having a glove at all, or would it still react violently? In any case, to make it, I'll just be needing two chemicals, potassium nitrate and concentrated sulfuric acid. So to start things off, I added 110 grams of potassium nitrate to a flask. Then on top of this, I poured in 60 milliliters of concentrated sulfuric acid. The moment it was added, it started reacting with the potassium nitrate to make nitric acid and potassium bisulfate. At room temperature though, this reaction is really slow. To get the reaction going, it'll have to be heated, and the best way to do this is to set it up for a distillation. To try to keep the boiling under control, I dumped in some pieces of porcelain that I got from a broken plate. All the joints needed to be sealed, but I couldn't use regular grease because hot fuming nitric acid would just tear it apart. So I instead used concentrated sulfuric acid, which is somewhat common when distilling super oxidizing and corrosive things. When I was ready to get started, I packed the receiving flask with some ice water and I turned on the heating mantle. After only like 30 seconds, it started to bubble a lot more, which told me the reaction was picking up. And only something like a minute after this, nitric acid started condensing on the sides. To retain the heat and to help the vapors escape from the flask, I insulated it with some aluminum foil. Above it though, I removed the foil to show you guys what was going on. As the reaction continued, more nitric acid was produced, and it slowly climbed up the adapter. Throughout the distillation, some nitric acid decomposes from the heat and makes orange nitrogen dioxide gas. I think the distillation took about 2 hours or so, and everything that came over was either at 83°C or slightly below it. As it continued, the stuff in the flask slowly dried up, and more nitrogen dioxide was being produced. It eventually looked like there was little to no liquid left, and the nitric acid pretty much stopped coming over. So I took away the heating mantle, and I ended the distillation. To measure the yield, I poured it into a grad cylinder, and I got a volume of about 28.5 mils. Then I weighed it and got a mass of 43.1 grams. By dividing the mass by the volume, I found that it had a density of about 1.51. I was then able to use a chart that I found online, which correlates the density of nitric acid with the concentration. So at 1.51 grams a mil and room temperature, I got that the concentration was between 99 and 100%, which was significantly more than I expected. Okay, now for the fun part, where I see what happens if I get some on my skin. And at the same time, I figured I'd contrast it with what it can do to gloves. So I shot some onto my finger, and I had the excess drip onto some pieces of a nitrile glove. They very quickly lit on fire, but on my finger, I didn't feel anything. The moment it started to hurt even slightly though, I quickly washed off the acid. I also kept rinsing my finger for several minutes to make sure that all of it was removed. My finger afterwards was stained yellow because the nitric acid reacted with keratin protein in my skin and nail. This is pretty typical though with nitric acid, and it even happens with the normal lab grade stuff. I then soaked it in a solution of just baking soda to make it slightly basic, which turned it to more of an orange color. There wasn't actually a real purpose in doing this. It's not to neutralize the acid or anything. I just thought it was kind of interesting. In general though, I felt like it looked a lot worse than it was. The damage was mostly superficial, and it didn't even make it past my dead skin layer. So as long as it's washed away relatively quickly, I feel I can agree that wearing no gloves is probably the better option. In the lab, the two most common glove types are nitrile and latex, and I wondered which would be worse to be wearing if you got the acid on it. The first run was with the nitrile glove, which lit on fire within about 3 seconds. One thing to keep in mind though is that the acid heats up very quickly and it can burn you even before it ignites. So the actual amount of time that you have to get it off might be less than 3 seconds. With the latex glove, it took about 4 seconds to ignite, which made it seem like it was slightly better. However, after I put it out and picked it up, it stuck to the dish a bit. So although it takes longer to light on fire, it might be harder to remove and it could even get stuck on you. From this, it seems like the latex would be worse. The nitrile reacts quicker, but it doesn't melt and it might be easier to remove. In the end though, you should definitely not be wearing either of them. Just for fun, I also tested it on some disposable vinyl gloves. I've actually never seen them used in a proper lab before, and I rarely use them myself because I find they don't really fit well and they also break easily. I honestly expected them to just light on fire like the other ones, but the results surprised me. I even let it sit there for quite a while and it didn't look like anything was really going on. So based on this, they might be a viable alternative to working barehanded, but I don't really feel comfortable guaranteeing that they're safe or anything.